Since section 2.1 on sequences and summation notation was a little lengthy, I decided to separate it into two separate videos. This will coincide with what we did for the second day of the lesson. So when we ended the first day, we were talking about finding these things called partial sums, which is something that's going to help us out as we move from pre-calculus into calculus. So let's find the first four partial sums and the nth partial sum of the sequence defined by a sub n is equal to 1 over n minus 1 over n plus 1. Now remember, the first sum is basically the first term of the sequence. It's 1 over 1 minus 1 over 1 plus 1. The second sum is going to be what we got for the first term plus what we get when we plug in 2 for n, which is 1/2 minus 1/3. Now notice that the halves are opposites. They end up canceling. So you're left with 1 minus 1/3. The third partial sum is going to be 1 minus 1/2 plus the second term, which is 1/2 minus 1/3, plus the third term, which is going to be 1/3 minus 1/4. And again, I want you to notice opposite halves, opposite thirds, and I'm left with 1 minus 1/4. And then the fourth partial sum, 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4. And the next one's going to be plus 1/4 minus 1/5. And the 1/2s cancel, the 1/3s cancel, the 1/4s cancel, and you're left with 1/2 minus 1/5. So the nth partial sum is going to be the definition that we can use for finding any sum in this particular sequence. Well, I want you to notice that, oops, I messed up the last one, didn't I? It's going to be 1 minus 1/5. Sorry about that. Okay, so now what I want you to notice is in each of the final answers for the sums, all of them have a 1. So the nth term is going to be 1 minus 1 over, well, each of the terms, each of the fractions in the sums is going to be 1 more than the number you plug in at the very beginning. Remember that when we're finding the terms in a sequence, the first number we plug in is 1. So the only way to get a denominator of 2 in the first sum is to add 1. And this would be the definition for the sum. This big funny looking E is the Greek letter sigma. And we see a lot of Greek letters in use in both math and physics. Well, for our purposes, the Greek letter sigma is sigma notation or summation notation. It basically means add up a whole bunch of stuff. And so the way this works, and it's a precursor to calculus, there's going to be a starting value underneath the symbol and an ending value above it. That means we're going to plug in every number from 1 until n into this expression. And then we're going to add all those terms together. That's how sigma notation works. So let's look at an example of how summation notation works. I want to find the sum from 2 to 5 of the expression 2k plus 3. So the first thing you're going to do is you're going to plug in 2 for k. So 2 times 2 is 4 plus 3 is 7. Then you're going to plug in 3 for k. 2 times 3 is 6 plus 3 is 9. Then you're going to plug in 4 for k. 2 times 4 is 8 plus 3 is 11. Then you're going to plug in 5 for k. 2 times 5 is 10 plus 3 is 13. And then you're going to add those numbers together and you're going to get 40. And that's the sum from k equals 2 to k equals 5 of 2k plus 3. Let's try one more. Let's find the sum from k equals 1 to 5 of k squared. Well, all you have to do is start by plugging in 1. 1 squared is 1. Then you plug in 2. 2 squared is 4. Then you plug in 3. 3 squared is 9. Then you plug in 4. 4 squared is 16. Then you plug in 5. 5 squared is 25. And then you add those all together. And you get 55. Now let's go the other direction. What if I have all the terms in a sequence and I want to go back and I want to write it in summation notation? Well, first of all, I'm going to put my big old sigma notation here. Now, the starting value, I want you to look at this sequence very carefully. What's the only thing that's changing? Well, the only thing that's changing is the base of those exponential terms. So the first number is going to be 1 because we have 1 to the third. The last number in the sequence is 7 to the third, so we're going to go all the way to 7. Well, what are we plugging in? K. And notice that all of them have an exponent of 3. So the summation notation that reflects this sequence is the sum from k equals 1 to k equals 7 of k to the third. Now let's look at the next one. We want to find the sigma notation that represents this sequence, square root of 3 plus square root of 4 plus square root of 5 plus dot 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 square root of 77, sorry. Alright, so I'm going to start by putting my big old sigma notation. Now, what's the only thing that's changing? The only thing that's changing is the number that's under the radical. So I'm going to say that this is probably a square root of k. And we're going to start at, looks like it starts at 3, and then it ends at 77. However, that's not the only way to write this particular expression. Remember we talked earlier about doing those sequences where the first number we always plug in is 1. Well, another way of writing this is, what if I started at 1 instead of 3? What would the expression under the radical be? It would be k plus 2. Because if the first number I plug in is 1, the only way to get 3 is to add 2 to it. And then I wouldn't be going to 77 this time. If the last number is 77, then I would only be going to 75. Or another way of writing this is, what if I wanted to start instead at 0 instead of starting at 1? There's really no rule to how this works. If I wanted to start at 0 instead, the only way to get 3 under the radical is to take the k and add 3 to it. And then I wouldn't be stopping at 77, I'd be stopping at 74. So there is no unique way of writing this sum and sigma notation. All of these answers are correct. It just depends on which way you'd like to do it. There's one last thing that I want to mention, which is how to do summation notation on the calculator. There is a way of doing it. I haven't introduced it in class. If you hit second stat on your calculator and then you arrow to the right, option number 5 says sum. And I wrote 1 instead of 5. Let's make that a 5. So you hit enter. And then you go to second stat a second time. And this time you only go 1 to the right under ops. And then option number 5 says sequence. Now if you have the newfangled calculator, the next thing that happens is it pops up with a screen where I think it says something like expression or equation. If you were, for instance, to do this problem, the summation notation from k equals 2 to k equals 7 to 2k plus 3. In the expression part, you would type in 2x plus 3, because the variable we have to use in the calculator is x. Then the next thing, I believe it said variable. I'm trying to remember what my calculator looked like earlier. And then you would type in x. And then the next one wants to know what your starting value is. So you would say that the starting value is 2. And then it says what's your ending value. So you would say your ending value is 7. And then the last one, I think it said like print or something to that effect. And then you go get your cursor on that and hit enter. And what pops up on your screen looks like this. Oh, I know what I forgot. There's one here in between that says increment. Sorry about that. The increment, you just type in 1 every time. And then after this pops up on the screen, you hit enter. And then it'll pop out the answer for you. And the answer should pop up then is 75. And you may want to try that on your calculator yourself.